Well, good afternoon, grade 10s, and welcome to another session of mathematical literacy. I'm sure you're enjoying your maths this year, hey? Of course you are, because for the first time in your life, you're not worrying about algebra and X's and Y's and Z's. We're dealing with some good stuff. We're dealing with real life situations. And today what we're going to do is we're going to look at some more real life situations. And we're dealing with a portion of the syllabus that falls under that title, statistics. And we're going to learn about something called representing data. Okay, so what do I mean by representing data? Well, in our last episode, we would have looked at how you would go about collecting information from different people for whatever reason. And then once you've got all that information, you've then got to do something with it. You've then got to represent that information. You've then got to show that information. And the way we do it is by doing different charts and different diagrams. And that's what we're going to look at today. It's great stuff. It's exciting. And it's one of the parts of the syllabus that I really do enjoy. And hopefully by the end of this session, you're going to say, you know what? Oh, I think this is one of my favorite sections as well. So let's have a look at it. So we're looking at representing data. And in this section, we're going to look at ways of representing data in an easy to read format. We're going to be looking at representing data in a table form. We're going to look at this thing called tallies. We're going to look at stem and leaf diagrams, representing data in a picture form, looking at pie charts, bar graphs, and finally looking at histograms. So without any further ado, let's get going. Right, tallying. A table is a convenient way to represent data that have a numerical element to it. Tallying events can create an easy way to see the number of incidences of an event that took place. If we measure someone shooting baskets for a basketball team, we can make a tally mark every time the person scores. This would look as follows. Okay. Now, we interpret this as Tabu scored 9 baskets. This is known as tallying. Now, guys, I want to stop and I want to bring something very important to your attention here. Every time we want to recognize something, so in the example that we were reading about, Tabu was busy playing some basketball, and every time he scored a shot, we would make a little mark. Now, in total, in that game, he scored 9 goals. How do we show that? Let's go back to this diagram and show how we would represent this. We would say he scored 1, he scored another, and he scored another, and he scored another. Now on his 5th goal, instead of drawing a line down, we're going to make a cross through that. Why do we do that? We do that so if I just glance at that whole set of data, every time I see this appearing, let's do it in a different color. Every time I see one of those things, I know that represents the number 5. And then my next goal, I'm going to say there's another, there's another, there's another, okay, and there's another. So just by looking at that, I can say, you know what, there's 5 and 4. That makes a total of 9 goals. Okay, it's easier than saying 1, 2, 3, 4, 5, 6, 7, 8, 9. And then at the end of it, having to count up. Now, how many is that? 1, 2, was that 1? I'm not sure. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 9. Because you can make so many careless mistakes doing it that way. Especially if we've got like 40 or 50 ones all next to each other. So much easier. 1, 2, 3, 4, 5. And every time we see a line going through a set of 4 digits, we know that represents the number 5. So it's easy to tally. So for example, let's have a look at this. Let's say I gave you this. Now looking at that, you can see, oh, that's easy. 5, 10, 15, 20, 22. How easy it is to read that. Rather than which is easier? Of course, folks, this way is a lot easier. Okay? rather than that. Because now we've got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, did I include that? Oh, no, let me start again. 1, 2. Do you see it can get so confusing? So that's what we call a tally. Every time we see something or representing a number or representing a situation, we make a little mark. Once we've got 4 marks, the 5th mark, we draw a line through it. So when we get something called a tally table, what is a tally table? A tally table is when we've got a whole table with a whole lot of numbers. So for example, this. Let's say we say to a group of kids or a group of students, what grade are you in? And what we're going to have then is we're going to have a tally table. We're going to say the grade, the tally, and then finally we're going to have the word frequency. Okay. And what does all that mean? Well, we know if you're in high school, you're going to have grade 8, grade 9, grade 10, grade 11, or grade 12. Now, we could do this. We could ask everyone individually, and people come through and they tell me the answer. We say, what grade are you in? They say grade 8, and we make a little mark, grade 8. What grade are you in? They say grade 9, and we make a little mark. So I'm going to make a whole lot of little marks. Let's watch. And someone says grade 10, and grade 10, and grade 8, and grade 11, and grade 9, and grade 12, and grade 11, and grade 10, and grade 10, and grade 10, and grade 10, and grade 9, and grade 8, and grade 11, and grade 12, and grade 8, and grade 9, and grade 10. And grade 10 and grade 10 and grade 11 and grade 12 and grade 11 and grade 11 and grade 8 and grade 8 and grade 8 and grade 10 and grade 10. Sure. So many people walk past now, I had to ask them all. Okay. Now we're going to actually add all those little tally marks up and look at the total. And the total we call the frequency. So now let's add this up. I've got 5 and 2 is 7. I've got 4. I've got 5, 10, 11. I've got 5, I've got 6, and I've got 3. So this table over here, this whole thing that I'm showing or squaring off here, putting in a rectangle, that is called my tally table, where you've got possible answers, you've got what the tally is, and finally, you're showing the frequency. That's a frequency table, or some people refer to it as my tally table. But the tally is all those little digits. Right, let's go on. Now, we get asked, create a tally table for the following. Paul, Fatima, Sibisu, and Tandi are collecting cans for their class recycling project. Over the week, they collected the following amounts. Paul collected 17, Fatima 22, we got 40, and we got 36, right? So now what we're doing is we're saying, okay, let's see how many cans they have collected. Now, obviously, it's over a period of time. So as they bring in the cans, so we're marking them off. We're not going to say, right, let me count all your cans, now let me make the tally. That would be silly. Okay, because then we could just write the answer. So we know that in total, Paul brought in, how many did we say? 17 cans. So we're not going to say, Paul, how many cans? 17. Okay, let me make 17 little marks. No, no, no. When are we going to use tally? We're going to use tally because Paul will come in and say, got 3. Okay, great, he's got 3. The next day he brings in 5. Okay, we make another little 5. The next day he brings in 8. We make a little 8. Okay, and that's all we're doing. Once the week is over or the month is over, and we've got all these little tally marks, then we can count it. Now let's just go again. We're going to look at this and show once again how easy it is to count tallies when we've made groups of 5. So let's have a look at this. Paul, 5, 10, 15, 17. Okay, is that right? It's right. Fatima, 5, 10, 15, 20, 22. Is that right? It's right. 5, 10, 15, 20, 25, 30, 35, 40. Is that right? It's right. 5, 10, 15, 20, 25, 30, 35, 36. Is that right? It's right. Okay. Tallying is just such an easy way of helping you count when you've got to count bits of information as it's coming in. Right. So we might say, who does this can belong to? Belongs to Paul. This one belongs to Fatima. This one belongs to Tandi. And so we're just making the marks as the cans are coming in. It's not if someone brings in a whole lot of cans and says, here it is, my total's 36, then we're not going to make, then we're just going to write 36. Do you understand where tallies come in? And they really, really are helpful. Right, let's move on. Next one. Stem and leaf diagrams. Now, when data gets more diverse or larger in terms of the number of items, a tally table may not be as convenient. A stem and leaf diagram is useful for data entries that can be grouped into larger categories of numbers. In worked example 2, we will use the marks that students received in a test to draw a stem and leaf diagram. So let's look at that example now. The following marks were received in a mathematical literacy test. So we've got a class and they get a whole lot of marks. And here are the marks. 19, 34, 56, 89, 23, 64, 69. Now guys, the way we can write that down to make life easy for us is we can write the first digit, okay? So 0, which represents any number from 0 to 9. A 1, which represents any number from 10 through to 19. A 2, which can represent any number from 20 to 29. What do I mean by that? Let's have a look at this. Okay, here's my stem and leaf. Now, when I want to represent the number 19, I've got a 1 this side. I'm just going to write a 9. Okay, if I had the number 45, I'm going to have the 4 there, and the 5 goes next to it. So let's have a look at these, and I'm going to draw my own table. If I had 0, 1, 2, 3, okay, and let's say I now wanted to represent the number 13. I'm just going to write a 3 next to the 1. Why am I doing that? Because the 1 is going to symbolize the tens unit, and the 3 is the unit. What happens if I had the number 16? Well, I'm just going to write a 6. If I had the number 19, a 9. What happens if I had the number 10? I'm going to write a 0. So that 3 doesn't represent 3, it represents 13. The 6, 16. The 9, 19. The 0, 10. 1 and 0 is 10. What is this number over here? 38. What about this number? 30. Okay, that's supposed to be a 0. 30. What is this number here? 29. Now, think about this. What's that number? Well, what's 0, 2? It's a simple number of 2. Do you see how these stem and leaf diagrams actually help us? Right? And why do we call it a stem and a leaf? Because a stem has a whole lot of leaves attached to it, and they all attach to the one stem. And in the same way, if I've got 28 to 29, the 8 and the 9 is both connected to the 20s. So that's what we call a stem and leaf diagram. Right. Now, another way of representing data is in the form of pictures. Now, we are going to look at a great picture that gets used a lot in newspapers, in pamphlets, and that is this whole thing called a pie chart. Let's read about it. A pie chart is a great way to represent data that makes up a convenient whole. Any data entries that together create a unit can be represented as a pie chart. A pie chart may look as follows. Right, let's have a look at that. So, where am I going to use a pie chart? I'm going to use a pie chart if I want to show a lovely picture of where certain things or the size that certain things make up of a full category. So for example, let's say I'm going to break up my day and I'm going to say I spend so much of my day sleeping, so much of my day eating, so much of my day studying, so much of my day watching TV, and so much of my day just doing my own thing, right? My day is a whole. It's 24 hours. And that makes up my whole circle. But that whole circle is going to be divided into certain categories. The sleeping, the studying, the eating, very important, watching TV, and my leisure time. All right, just in case you thought TV wasn't leisure. Now, in this example, what we've got here is we've got sales. So we've said, right, let's take all our sales and let's break it up into different categories. And what are our categories? We're going to say, well, the blue shows how much sales we made in the first quarter of the year. Now, that's quite a bit, hey? That's this whole section over here shows the sales are made in the first quarter of the year. The red represents the sales we made in the second quarter. My green represents the sales I made in my third quarter. And finally, the purple is showing the sales that were made in the fourth quarter. But can you see that all together, the sales in the one quarter, quarter two, quarter three, quarter four, those sales in those different little quarters make up all the sales. So as soon as I've got a whole, okay, like all my sales, and I want to break it up into categories, a great way of doing it is with a pie chart. Take my whole day and break it up into different categories or different segments. Okay, so let's go through this. It says the chart above represents a whole year's sales for a company. The year has conveniently been broken up into 4 quarters of 3 months each. From the chart, we can see that the sales were the best in the first quarter and the worst in the fourth quarter. The full circle represents the whole year. Okay. Now, I'm not sure what business would do better in the beginning of the year than at the end of the year, because normally at the end of the year it's Christmas and everyone buys. But maybe these are textbook sales. When people don't want to buy a textbook at the end of the year, they're sick of school. They'd rather buy their textbooks in the beginning of the year. And so that's what happens. They buy a whole lot of textbooks in the beginning of the year. And from that diagram, we could see that in this case, we've sold a lot of our books in the first quarter. Maybe in the second quarter, we're like, well, we got June exams and we've just lost our textbook, so let's buy another one. Or we can say, you know what, we still haven't ordered textbooks. Let's order some textbooks for our students. The fourth quarter is the least, because hopefully you all have textbooks by then and you're not going to buy very much. That's just a silly example. But can you see how it all works? Whole year sales broken into different segments. Next thing, represent the data in a pie chart, okay? Or rather, represent the following data in a pie chart. In a school grade of 100 learners, 25 have cell phones, 50 have no technology access, 10 have laptops, and 15 have computer access. To answer this question, we need to find the percentages of each category and then calculate the number of degrees that each category represents in the circle. Prepare a table as follows. Okay, now let's have a look at it. So what we're saying is this, that we have a certain category, we have a percentage, and we have degrees, and we'll talk about those degrees just now. But what we're wanting to do is we're going to say we've taken 100 students, the whole body of 100 students, and of those 100 students, we're going to break them up into different segments. We're going to say how many of those students have no access to technology. How many of them have cell phones? How many of them have computer access? And how many of them only have laptops? So that's what we do. And from the information, they said 50 of 100 of those students have no access. In other words, 50% of the students have no access. Now, how do we show 50% in a pie chart? Okay, well, pie chart is not broken up into percentages. It's actually broken up into different degrees. Okay, so each pie chart has how many degrees in it? How many degrees in a circle? 360. Absolutely. So we've got to try and change percentage into degrees. So if I have 50%, how do I make that into degrees? Well, it's quite simple. I'm going to say, right, I've got 50 out of 100. I'm going to change it to degrees. How do I change it to degrees? I times it by 360, because there are 360 degrees in a circle, but I only want 50 out of 100 of those. So we're going to say, right, so we've got 50 over 100, and we're going to multiply it by 360 degrees. What is my answer? 180. And there you can see 180 degrees. Okay, there it is. 25 over 100, how do I change that to degrees? Well, in the same way, hey? Instead of 50, we're going to say I've got 25 over 100. And 25 divided by 100 times 360, let's have a look at it. 25 divided by 100 multiplied by 360 equals 90 degrees. So again, we've got 90 degrees, and you can see that answer over there. So once we've done that, our pie chart is going to look as follows, right? You can see 180 degrees was no access. 90 degrees was only cell phones. We had 54 degrees of computer access. So 54 degrees had access to computers. And finally, we had what was left, 36 degrees had access to laptops. Okay. Now, I don't think in grade 10 they're going to ask you to draw pie charts. Your teacher might well want you to, so you can learn how to calculate different degrees. I know I ask my class that in class time. I say, right, we're going to draw our own pie charts. In exam, I don't normally do that because it takes such a long time. But what I do ask my students in a test and an exam is this. If I've got 50% of my students who got an A, how many degrees would that be in a pie chart? We've got to know how to do that. Folks, it's time for a break, so let's take it. Don't go away, though. I'll see you afterwards. Welcome back, grade 10. Just before the break, we were looking at different ways of representing data. And the two ways we'd looked at was, first of all, we looked at things called tallies and how we can use a tally table or frequency table to make some sort of order of our data. And then what we did was we looked at pie charts. And with those pie charts, we realized that a pie chart is a whole thing. So, for example, we used we said if I had my day, my whole day, it consists of 24 hours, but that day can be broken up into different segments. Maybe I'm spending a bit sleeping. Maybe I'm spending a bit of the day studying, a bit eating, a bit watching TV, a little bit having leisure time. Right. Now, another way we can represent data is with bar charts. Right, let's read about this. So, bar charts. These charts are useful for representing data where a comparison of values is important. The comparison of values is clearly identified in the heights or lengths of the bars. A key on the side of the bar chart gives the range of values being considered. We use these charts for data known as discrete data, and we'll talk about that just now. This simply means that the categories in each section are separate entities from each other and do not necessarily represent an order or follow on from each other. The items in the category are also measurable in whole units. Sure, that's a lot of language for what I'm wanting to get across to you. So let me put it in simplistic terms. Okay, so if I have some data, let's say, for example, I ask you this question. What movies do you enjoy watching? And we can say, well, we've got some comedy, and a lot of people really enjoy a good comedy. I know I do. We've got a horror, which is really, really scary stuff. And not many people enjoy horrors, except those horrible little boys who like to scare people. Then we've got romantic things, and this is when all the girls say, oh, that's so nice, okay? And then what else could we have? We've got comedy, we've got horror, we've got romantic, and let's make up another category of suspense, okay? Okay, so suspense, a real wonderful, interesting, like cop things. Now, comedy, we could say, you know what? We've got 15 people who enjoy comedy. We've only got one person who enjoys a horror. We've got 10 girls in our class, and they all say, oh, romantic is so nice. Suspense, we've got 3 people who enjoy a suspense. Now, how are we going to draw that as a bar graph? The first thing you need to understand is this, that I have my movies categorized in certain categories. I've got comedy, I've got horror, I've got romance, and I've got suspense. And I'm going to now draw a chart that shows me how many people enjoy different things. So the first thing I'm going to do then is this. I'm going to say, let's draw a set of axes. There's one, and here is another. And now what I'm going to say is I'm going to call this set of axes, I'm going to call it the frequency. What does frequency mean, folks? Get used to that word, hey? It's a word in Mathslit that you're going to use from now all the way through to matric. So get used to it. Frequency means the number of times it occurs. Okay. My horizontal axis, and let's just sort that out as well, hey? Do you remember when you were in grade 9, they called this axis the y-axis, and they called this axis the x-axis? Well, thank goodness we're doing maths literacy, because we don't talk about x's and y's. We're going to talk about our vertical axis and our horizontal axis. So our vertical axis, we're calling the frequency. Our horizontal axis, what are we going to call it? Well, in this example, we're going to call it the types of movies. So let's write that down here. Types of movies. And what types of movies did we have? Do you remember? We had a good comedy. What else did we have? A horror, romantic, and suspense. Now, folk, you would be expected to write out all the words. Comedy, horror, romantic, suspense. If you can't fit them horizontally, just write them vertically underneath that axis. Okay? Now, my frequency, what's the highest number I need? I need 15. So let's draw that in here. I'm going to say here I've got 5. Over here I've got 10. And finally over there I've got 15. How many people enjoyed a good comedy? 15 people enjoyed a good comedy. So let's draw that in straight away. So I'm going to say, right, I've got 15 people. Let's use a different color. Let's go pink. 15 people enjoyed a good comedy. Now, people, I'm not using a ruler, which is a bad thing, but I don't have a ruler here, so I can't really draw it. But you would always use a ruler. We'd want nice straight lines. In fact, let me try and get this as straight as I possibly can. Okay? Because we want the person who's marking your exam to say, sure, I'm impressed with this person. They've taken a lot of time to do this exam. Let me take a lot of time over marking it. So let's try and get a bit of a straight line. Okay? And that's what I'm going to do here. So we're going to say comedy. We got 15 people. There it is. And let's go all the way up to 15 and draw a line across. Great. How many people enjoyed the horror? I think there was only one in the class that liked a horror. So let's draw a line that shows only one person. And there we've got one little person who liked our horror, and we're drawing a line across. Okay? How many people enjoyed a romantic? Remember, there were 10 girls, and they all said, oh, we just love a romantic, and they got all gushy and washy and like sad about the whole thing. So 10 of them enjoyed a romantic. How many enjoyed the suspense? Only 3 of them enjoyed a suspense. So let's go up to round about 3. Okay? Now, what I want to say to you is this. It is quite difficult to get this accurate on this screen, but you at home, you've got a nice ruler. You can draw your graph perfectly. But few things I want you to take note about a bar graph. Let's have a look at them. The first thing is this. I have got a title for my graph, and let's call it something. What shall we call it? Movies enjoyed by grade 10 scholars. Okay, so first thing about my bar chart, I've got a title. I've also got 2 other semi-titles, and that's the name of my vertical axis and the name of my horizontal axis. Let's have a look. The name of my vertical axis was frequency, and my horizontal axis we called types of movies. Then our frequency we actually numbered. You can see I've got 5, 10, 15. It would actually be a lot better if I could label 1, 2, 3, 4, 5, because then if I want to draw a block up to 1, I'll be accurate. Drop up to 3, I'll be accurate. Okay? And you can do that in class because you've got the ruler and you can be a lot more accurate than I am at the moment. And then at the bottom, besides calling my horizontal axis types of movies, I'm also naming the movies. So I've got comedies, I've got horror, I've got romantic, and I've got suspense. So that's the first thing, my different titles. The next thing you got to notice from a bar graph is that I've got exactly what the name says, bars. So I've got little bars, and those bars are not touching each other. Why are they not touching each other? Because I've got different categories of movies. Later on, we'll see when the graphs do touch each other. But for now, a bar graph, we're going to say the categories aren't touching. So I've got here a complete category of just comedy. There it is. That whole bar graph is just comedy. This whole bar just represents horrors. This whole bar just represents romance. And this bar over here represents the suspense. Can you see that? So the bars have gaps in between them. And normally I try and draw my bars the same width as well. And that is one of the ways of representing our data. So far we've looked at 3 ways. 1, tally method with all those little lines. 2, a pie chart. And our third one we've looked at is our bar chart. Right, let's move on. Now, here's a question. In our high school, the grade 8 to 12 groups held a competition to see which grade could collect the most money for a charity. The results were as follows. Grade 8, 520 Rand. Grade 9, 700 Rand. Grade 10, 460. Grade 11, 1,200 Rand. Grade 12, 930 Rand. Represent this data in a suitable chart. Okay, so a pie chart could work for the data above, but it would not instantly be clear which grade won. Instead, the bar chart would give an instant result as to the winning grade. We could mark the left-hand side of the chart in suitable units, perhaps 100 or 200s, so as to get a range from 0 to 1,200. Below is an example of the chart. So what this question's actually saying, and the way they've answered it, is to say this, that I could represent this in a pie chart. I could say, let's look at all the money that was collected. We found the total money. And that total money can be broken up into little segments. How much did the grade 12s collect? How much did the grade 8s, grade 9s? The only problem with that in this example is this. can you see here, 520 and 460 are pretty close to each other. And because they're pretty close to each other, the segments would be almost the same size. They wouldn't be identical, of course, but they would be very, very similar. And it wouldn't be easy to look down and say, oi, the grade 10s collected the least amount of money. Or, gee, the grade 10s collected less than the grade 8s, or the grade 8s collected more than the grade 10s. Okay? It would be quite difficult to do that. It is possible, but that wouldn't really be the way we'd show this data. Instead, a good way to do it is by a bar chart. Let's have a look at that. Okay? So this chart very clearly illustrates the information we need and shows us that the grade ahead is grade 12. Who's collected the least? Oh, you can see that straight away. Grade 10, then grade 8, then grade 9, then grade 12, and then grade 11. So come on, grade 10s, you need to collect more money. All right? Do you understand that? But now let me just make something very clear. I don't believe it would be right for any teacher to say to you, here's some information, represent this information in a chart that you've learnt about. I think that's a bit unfair. I think a teacher would rather say, you know what, here's information, draw a bar graph to illustrate this information. Or here's some information, draw a pie chart to illustrate this information. Unless your teachers are giving it to you as an assignment, which I would do to my grade 10s, I might give them a set of data and say, represent this data in 2 different ways. Then they could draw a pie chart and a bar graph. Or I could say, represent this data any way you choose to. But I wouldn't do that in a test. I'd probably just do it in a worksheet or as an assignment. Okay, so there's our bar chart. Now the next way of representing data is in the form of this huge word called histograms. Now, these charts look very similar to bar graphs, except that the bars are not separate like those on the bar chart. Okay? So where we had a bar chart, we had information in bars, and the bars weren't touching each other. Do you remember that? We had separate bars. Now a histogram, we have bars that are touching each other. And why do you think that's the case? Let's read on. This is because the data categories represent continuous data, or data that follows on from the previous category. Usually the categories would represent a range of values. What do I mean by that? Well, do you remember when we looked at movies? We had horror or comedy. They were 2 totally different categories. Here's another way of looking at it. Let's say I asked you, what's your favorite color? And someone said, hey, they like red, others said they like green, some said they like yellow, and some said they like blue. Right? Now, you like either one of those colors. You can't suddenly say, you know what, I like Grio. What's Grio? You can't say, well, that's a combination of green and yellow. No, that makes up a totally different color, right? It makes up an entirely different color, and we give that another name. So I can't say I like red and green and say I like green. There's no such thing as green. If I mix red with green, what am I going to get? I think I'm going to get a yellow or a brown or something, okay? It's going to be a different color. And because of that, I've got different categories, different bars. But now, if I were to say this to you, all right, let's get rid of the colors. Let me ask this question. How tall are you? And you say, you know what, I'm 171 centimeters. How tall are you? Oh, well, I'm only 150 centimeters. Shame, I didn't learn to grow. How tall are you? Oh, I'm quite big, hey? I'm 201 centimeters, which is more than 2 meters tall. How tall are you? Oh, shame, you know, I just haven't learned the art of growing. I'm only 135 centimeters. Okay. And so I ask a whole lot of people how tall they are. Now, if I wanted to show that information, guys, it's very hard to draw separate bars for all that, because I'm going to have one bar for 0 centimeters, one for 1 centimeter, for 2 centimeters, for 3 centimeters, for 4 centimeters. In fact, I might even have to have a bar for 150,1 centimeters, or 150,01 centimeters, and another bar for 150,02 centimeters. I'm going to have millions of bars. So what I say is, you know what? Let's take this dot and put it into little categories. And I'm going to say, right, how many people are smaller from 0 up to, let's say, 120 centimeters? Or greater than 120 up to, let's make that greater, up to 150 centimeters. Greater than 150 all the way up to, let's say, 160 centimeters. Greater than 160 all the way up to 180 centimeters. Greater than 180 all the way up to 200 centimeters. And then greater than 200 centimeters. Now, what have you noticed? All my units are the same. I'm talking centimeters. I'm not talking red, yellow, green. I'm not talking horror, comedy, suspense. I'm talking centimeter, 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 centimeter. In the same way, if I ask people how much do they weigh, they could say, I weigh so many kilograms. I weigh so many kilograms. I weigh so many kilograms. And again, it would be kilograms, 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 the same unit. Now, folks, as soon as I have the same unit, then I don't need separate bars. Then I can have bars that are touching each other. So let's have a look at this. Let's say I drew a set of axes. Let's just get this quickly. Here's one. Oopsie, let's just move that. And here's another. Okay? And I'm going to say, right, in fact, let's just get rid of that one. Can we? No, we're not. Okay, there we go. Let's just move that out the way. And let's draw, oops, it's not going out the way. There we are, it's gone. Let's draw another one quickly from here all the way up. Now what I'm going to do is I'm going to say, right, I asked centimeters. And I've got a category here between 0 and 150. I've got a category here greater than 150 up to 160. I've got from 160 to 180. And I've got greater than 180 up to 200. And then I've got greater than 200. Okay. Now, how do I draw those? Well, first of all, my graph is going to have a name. And we're going to say the height of grade 10s. Do you remember we did the same thing when I had the bar chart? We had to have a title. So we've got a title here. What did we have down our vertical axis? We had frequency. So let's do that as well. We're going to have frequency. In other words, the number of students that are a specific height. At the bottom, at our vertical, we're also going to have a little title or a heading, and we're going to call this the height in centimeters. And I love saying in centimeters. The reason I like putting that in the title is so every measurement I do, I don't have to write centimeters at the end. So if my title says the height in centimeters, I don't have to say from 0 centimeters to 150 centimeters. From 150 centimeters to 160, I can just say 0 to 150, 150 to 160. Why? Because my heading had it there. Can you see that? In centimeters. Now, so far there's no difference between my bar and my histogram. But now the difference comes. So how many students were between 0 and 150? And I'm going to make this up as I go along because I'm just using this as an example. So in grade 10, I've got 5 students that are between 0 and 150 centimeters. I've got 10 students between 150 and 160. There we go. I've got 8 students that are from 160 to 180. 5 students from 180 to 2 meters, and I've got 1 student who's longer than 2 meters. Can you see now how my graphs or my bars are touching each other? Why are they touching each other? Because at the bottom, my horizontal axis, I I've got all the same unit. They're all centimeters. Okay? Instead of having red, green, yellow, or comedy, romance, suspense, I've got all centimeters or all kilograms. And it's a continuous range of those units. So, we've really learned a lot, eh? I think it's time for another break, and then we'll come back for another quick, short session and finally sum it all up. Welcome back, folk. We're really doing some exciting stuff here, hey? We're taking a whole lot of data and we're making sense of it, and then we're representing it in different diagrams. And so far, we've looked at representing data as a tally. We've looked at it representing data in the form of a pie chart. We've looked at a bar chart. And finally, just before the break, we looked at something called a histogram, where we had a whole lot of data or a whole lot of bars, but the bars were touching each other. Let's spend the last few minutes just looking at some examples. So let's have a look at this. So here now on our screen, we have a diagram. Now let's just try and remember what sort of diagram this is. Well, we know it's not a tally because a tally consists of a whole lot of little dashes all over the place, and there are no dashes here. It can't be a pie chart because a pie chart's got to be just that, hey? It's got to look like a little pie, circle, and the circle's got to be broken up into different segments. And that's definitely not what we've got here. And it cannot be a bar graph because although there are bars, the bars are touching each other. And when the bars touch each other, we know we've got a histogram. And when we've got a histogram, then we know what? We know that the units on the horizontal, so all these units over here, must represent the same thing. And in this case, they're all representing percentages. Okay? So let's have a look at this. So this histogram shows a continuous score from 0 to 100. We can read the frequency of the number of each range of scores. Example, there was one occurrence of a score in the range between 0 and 10, whereas there were 5 scores between 40 and 50. Note how the bars are connected because the scores have no gaps between them. In other words, the data is continuous and can take a variety of values within the range. Okay, now it's a lot of English all this, eh? But let me explain it in terms that we understand. What we're saying is this, that our data that we're looking at is scores that students have scored in a test. It starts from 0 and goes all the way through to 100. It's continuous. We're not missing out a few numbers. And because it's all a percentage, that's another indication that we've got a histogram where all the graphs are touching each other. There is a disadvantage to a histogram. Let's have a look at this. If you look here, we can see that one person scored between 0 and 10%. Here's the unfortunate thing. We don't know the actual score that that person got. We don't know if they got 0%. And we're not sure if they actually got 9%. We don't know that. All we know is that one person got somewhere between 0 and 10%, or from 0 to 10%. Okay? But we don't know the actual score. Can you see that? It doesn't tell us, okay, this is 5% and one person got 5%. No, it doesn't. It tells us one person got anything between 0 and 10. There it is. That's the one person. If we look at it as well, the nice thing about this is we can tell straight away which set of data, what was this class like. Well, I can see that most of the class got in the 40s, got between 40 and 50%. A lot of the class got between 30 and 40 and between 50 and 60. Sadly, this class is not the brightest class. Only one person got in the 90s. Another two, look at this, only two got in the 80s. So a total of 3 people got a level 7. Out of how many people? How many people in this class? Well, let's have a look at that. Let's go and get rid of all this and try and add it all up. So if I were to look at this, I would say I've got 1 here, I've got 2 there. Here I've got 3, I got 4, I got 5, I got 4, I got 3, I got 2, I got 2, I got 1. So how many people in the class in total? Well, we got 1, 3, 6, 10, 15, 19, 22, 24, 26, 27 people are in this class. And most of them got in the 30s, 40s, and 50s. So I would say this class is an average group of students. We got 1 or 2 kind of bright. Sadly, we got 1 or 2 that are not that bright. But an average class as a whole. Okay. Do you understand this whole thing of histograms? Okay. 2 important things about it is the data on the horizontal is all the same units and it's continuous, and the bars are touching each other. Right, time for an example, and now we're going to take all those things we've learnt about, okay? And we've learnt about the tally, we've learnt about a stem and leaf diagram, the pie chart, the bar graph, the histogram, and let's now just mix it all up and do some examples. And that will be a great way to end this session. So here we go. Draw a stem and leaf diagram for the following data, which lists the ages of people who attended a sporting event. So how do you remember about the stem and leaf? Let's go for it. So we're going to say we've got a 0, a 1, a 2, a 3, a 4, a 5, and a 6. I think that's as high as we need to go. And what we're now going to do is we're going to fill in the other numbers. So 12 is a 1 and a 2. 14, I'm just going to put a 4. 16, a 6. 23, 23, 25, 27, 28. 30, 31, 32, 39, 40, 42, 45, 51, 60. Okay, how nice is that? And just by looking at that, we can say, wow, we can see that most of our spectators were in their 20s and 30s. Right, easy, stem and leaf. Remember, the first digit represents the tens units. The second digit is representing the ones or the units. So 1 and a 2 represents 12. This 8 over here represents 28. Next example. What kind of pictorial chart would be suitable to represent the following? Now, hopefully you wouldn't get a question like this in your exam, but it's good to play around with this. I would give this to my class as a worksheet to see if they understand certain concepts, but I don't know if I'd ask them this in a test or an exam. But great for a worksheet or great for a portfolio piece. Right. Which is the best way to show how the government allocated funds from the budget? I think the best way of doing that would be as a pie chart, don't you? So we could say in our pie chart here, we have all the funds that belong to the government. And from that, what we're going to do is say, well, a portion of that went to education. A portion of that was spent on agriculture in the country. A portion of that was spent on, oh, I don't know, let's think of something. What could we spend money on? Exporting or importing goods. Do you understand? That's a great way of showing how the whole set of money is broken up to. How would we show the number of competitors entered in the Comrades Marathon from 1995 to 2010? Well, there are a number of ways. You could use a pie chart, or you could actually use a bar chart, couldn't you? you could have the different years and then the different categories. Or you could use it in a histogram, because here would be frequency and here would be the years. So we could have 1995, 96, 97, 98, 99, and then we could have all those showing how many people actually took place in the race that year. What about the temperature readings of a range of refrigeration appliances? Again, I would say a histogram, because at the bottom we're going to have all the degrees. So we could say anything from 0 to 10, anything from 10 to 20. And then we've got how many appliances are in that temperature. And remember, we'd use a histogram because these units would all be in degrees. The rainfall figures for the months of the year from 2011 for a city. Again, I would use a histogram. Why? Because all my units at the bottom would be in millimeters. Here's a nice one. The cyclists participating in various age groups for the 2004 7 cycle race. Well, that would be a nice one to do in bars. Okay? Or a breakdown of the floor space allocated to various store categories within a mall. So we could say, right, here's our entire mall. Of that mall, what's going to happen is we're going to make a whack of it belong to restaurants. This little bit here is going to be the amount of floor space allocated to clothing. This little bit here might be allocated to food. This little bit over here might be allocated to sporting goods. And this little bit over here might be allocated to cosmetics or something weird and wonderful like that. Okay? But you've got a whole floor space and we're breaking it up into different segments. Again, I must emphasize, I wouldn't ask this question for a grade 10 student, but it's good to be able to think and say, what would be a good way of representing this data? Here's a great thing I would do for my grade 10s. I would give them an assignment and I would tell them, off you go and you ask a question. You go out, you do a full survey, you then come back, you get all your data, you arrange it in order, and then you show that data in different picture forms. You might want to use some of your data and reflect it in a pie chart. You might want to show some of it in a bar chart, some of it in a histogram. But that's a fantastic assignment. And if you can do that, you can do any of this work we've spoken about in the last hour or so. Let's have a look at another example. Now, calculate how many degrees each of the following categories will need in a pie chart based on the percentages given. Now, folks, this is so important. It's even important in the matric final paper. And do you know we have some matrics that cannot do this? So now, while you're in grade 10, let's get this concept into our head straight away. So, the percentages of medals taken by various countries in the 2008 Olympics. So, what do we have here? We have a number of countries that have won some medals in the 2008 Olympics. And we want to show all the medals that have been won, and we want to break them up into different categories. How are we going to draw that? Well, the first thing is this. We know that 54% of the medals won came from the USA. Now, 54%, remember, what does the word percent mean? The word percent refers to out of 100. So percentage, whenever I hear the word percentage, I think straight away, oh, there's got to be 100 somewhere. So 54% is 54 over 100, or out of 100. Now, we're trying to draw a pie chart. How many degrees in a circle? There are 360. So how are we changing a percentage and moving it into a degree? We're going to say 54 over 100 multiply by 360 degrees. So let's do that. Times 360 degrees. Now our calculator is going to do the rest for us. We're just going to say, okay, so we've got here 54 degrees over 100, sorry, 54%. multiply that now by 360 degrees, and we get an answer of 194,4. So that's equal to 194,4 degrees. Now, the UK, we've got 28 degrees. So we're going to do the same thing with the UK. We got 28% rather, changing it 2 degrees, so we're timesing it by 360 degrees. Again, with our calculator, we say, right, I've got 28, I'm dividing it by 100, or it means 28 over 100, and multiplying it by 360, and I'm going to get an answer then of 100,8. So we've got 100,8 what? 100,8 degrees. So we know the USA of our entire pie chart makes up 194 degrees. UK make up 100 degrees. So now, what's going to happen when we draw this? Well, when we draw this, we've got a pie, complete circle. I know that I've got 90 degrees, I've got 180 degrees, I want 194. So it's going to be a little bit more than a half. And that's going to be the USA. And I would measure here with a protractor 194,4 degrees. Okay, I think it was 4. Yeah, it was. The UK is 100 degrees. So that would be around about 90. This would be round about over there. And this would be the UK. And that makes 100,8 degrees. And then slowly we would get a little bit for Germany, a little bit for Japan, and a little bit for other. So we'd break this little bit over here even further. I'm going to use a different color. A little bit here, a little bit there, and one would be so many degrees, another degree, and a little bit more degrees. Okay? I'd have to work each one out individually and then draw it. But can you see all the medals? And of all those medals, a huge chunk went to the USA. Another huge bit went to the UK. A tiny little bit went off to Germany. A tiny little bit went off to Japan. And a tiny little bit went off to the rest of the countries. Okay, easy? You understand this? Of course you do. Let's go on now and look at another question here. What scale would you use for the y-axis in the following sets of data? So, and I hate this word y-axis, hey? You can see this was written by a maths teacher and not by a maths lit teacher. Because we'd say, what scale would you use for the vertical axis? Okay, we don't like that y-axis at all. So what axis would we use for the vertical? Well, we've got rainfall data. So in rainfall data over here, we've got the months. Would you agree on that? What would be our vertical axis here? What scale would we use? We would say it's in millimeters. Do you agree? Okay. What would we use for the number of hours logged by workers in a company? So here we would have the names of the workers. And what would our vertical axis be called? It would be called hours. Got that? All right. This is straightforward, isn't it? It's really nice and easy. Folk, we have about 10 minutes left. And so what I thought we'd do now is sum up what we have done today. So the first thing is this, that we get a whole lot of data, and what we're going to do is we are going to represent this data. Okay. And how are we going to do it? Well, the first way we're going to do it is we can do it by means of a tally. So we can draw a whole lot of little lines that represent my data. And I can look at it and I can see straight away, oh, John brought in so many cans of cold drink. Or I can look at it and say, sure, so many people are between the mass of 100 kilograms and 110 kilograms. My gosh, that's heavy. Okay? How else can we represent the data? We can also represent this data by means of a pie chart. And then we can represent it by means of a bar graph. And finally, we can represent this by means of a histogram. A few things to remember with pie charts. Remember, a pie chart, we always have a circle, and a circle is made up of 360 degrees. Do you know how many matric students in a final exam, when they're asked to convert certain things into degrees, think there are 100 degrees in a circle? They get mixed up between percentages and degrees in a circle. So don't you dare do that. Do you hear me? Must be 360 degrees. Remembering as well that a bar chart is made up of a set of axes. It's got to have a title. It's got to have a name on my horizontal axis, a name on my vertical axis, okay? And then the graphs or the bars are not going to touch each other at all. So we're going to get a whole lot of bars and none of them are touching. And remember, the reason why none of them are going to be touching is because we're dealing with separate units the whole time. So we're dealing with things like color, where we've got a red and an orange and a yellow and a green and a brown and a purple. Or we're dealing with things like fruit, where we've got a banana and an orange and a plum and I don't know what else, lychee, okay? All separate units. And because they're separate little things, they each got their own little bar. Okay. Now, a histogram is very similar to the bar graph. Very similar. Because a histogram also has a set of axes. It also has a title. It also has a name on the horizontal axis. It has a name on the vertical axis. But where the difference is this, that my units here are all the same. So I'll be dealing with things like, for example, weight. And I'm going to categorize a whole lot of different weights, but the units are all weights. Or height in meters or centimeters. Okay? The units are the same. And it's continuous data. So, for example, if I wanted to take a set of results, it would be from 0 through to 100. And I'm not going to miss a few. Okay? It's going to be from 0 all the way through to 100. And my categories could be 0 to 10, 10 to 20, 20 to 30, 30 to 40%. So the only difference between histogram and bar graph is this, that I'm going to have bars that are going to touch each other. Okay? And that's the main difference between the two. So we represent data, we do it by means of a tally, on a pie chart, on a bar graph, or on a histogram, and bearing in mind that a pie chart always 360 degrees, a bar chart, separate bars, a histogram, bars, but that are touching each other. Well, we've really learnt a lot today, folk. A lot of stuff to take in. Here's a good idea for you. Why don't you do the following? Why don't you set yourself an assignment? Let's say your assignment is the following. You want to work out or you want to get some pocket money from your parents. So you want to ask different people how much pocket money they actually get, so that you can take this information and go to your parents and say, you know what, Mom and Dad, I need more pocket money. So how are you going to do it? Well, the first thing you're going to do is you're going to have to make up a little survey questionnaire. Remember, we're not going to ask people their name. So we're going to start off by saying, all right, first of all, what grade are you in? Why would you want to know that? Well, maybe you want to say to your parents, you know what, even the little grade 8s get more pocket money than I do. So maybe you want to know the grade. And finally, you want to know how much pocket money do they earn. And don't just get them to write a figure. Break it up into little categories. Okay? So maybe you've got from 0 to 10 Rand, from 10 to 20 Rand, from 20 to 50 Rand maybe, between 50 and 100, between 100 and 150, or 150 and 200. You make up your categories as you see fit. Once you've done all that, give it out to some students in your school. Get them to cross off what grade they're in and to cross what pocket money they actually get. Then take that information and draw up a tally or frequency table or tally table. So you've got, and you're marking off, as you're getting the piece of paper, you're marking off each one, getting another one, marking it off, getting another one, marking it off, okay? So you know how much money everyone is getting. Then take that and show that in represent that data in some sort of picture or table. So what you might want to do is say, right, I'm going to show how many grades or how many students in each grade are questioned. And then you'd want to do that as a bar chart, wouldn't you? You would have grade 8, I asked 10 people. Grade 9, I asked 20. Grade 10, I asked 50. Grade 11, I asked 5. Grade 12, I only asked 1 because I'm scared of them. I didn't want to go and ask them. And then you look at how much pocket money they earn. And then how are we going to do that? Well, I would do that with a histogram, where I've got all the amount of money at the bottom and the different categories. And I would draw it like that. And guys, if you can do that kind of an assignment, I tell you something, you understand everything that we've spoken about today. And what a better way of learning than doing an assignment yourself. That's all I have to say today. I trust it's been great. I trust you've learned a lot, and I look forward to seeing you again shortly. Cheers.